ഒരു 5 മിനിറ്റ്സ് കൂടി കഴിഞ്ഞിട്ട് നമുക്ക് സെഷൻ സ്റ്റാർട്ട് ചെയ്യാം. സോ ഗുഡ് ഈവനിങ് എവറി വൺ. എല്ലാവർക്കും പറയുന്ന കേൾക്കാലോ അല്ലേ? So this is the last session of our bootcamp. On this last session, we have Varada Balachandran, who is a DevOps engineer at Euroline, on the topic Kubernetes basics. Thank you so much, ma'am, for joining with us, and on to you.
Hi all. Thank you, Sanya. And let's get started. So, good evening. And have you have you heard anything about Kubernetes before? Anyone? ആരും കേട്ടിട്ടില്ലേ?
എല്ലാവർക്കും മൈക്ക് ഓൺ ചെയ്ത് ആൻസർ റെസ്പോണ്ട് ചെയ്യട്ടോ.
ഡോക്കർ അറിയില്ലേ? നിങ്ങൾ റെസ്പോണ്ട് ചെയ്യൂട്ടോ. ഓക്കെ, യാ, താങ്ക്സ്. So we'll start from zero. So like if you are an absolute beginner, don't worry, we'll cover up everything you need to know about Kubernetes and just the basics. So let me share my screen. I hope the screen is visible. Screen കാണുന്നുണ്ടോ? Like, can you unmute and tell? Okay. Yeah. So, what we'll be covering today, we start with why, like why Kubernetes exists and what problem it solves. And then we'll cover the key concepts and the architecture, like what is a Kubernetes cluster and what are the components inside it. And after that, we'll be having a hands-on session, like theory kondu matram കാര്യമില്ലല്ലോ. അപ്പോൾ let's have a hands-on session that will throw more light. Okay. So let's start with why Kubernetes. So എന്തിനാണ് Kubernetes? So before Kubernetes, the application deployment was a painful procedure. And like you will be SSHing into a server, copying the code, restarting the services, installing the packages, handling the versions, and everything. So when something got crashed, nobody knew until the real-time users were complaining. So maybe like around 3 a.m. അല്ലെങ്കിൽ 2 a.m. ഒക്കെ ആയിരിക്കും യൂസേഴ്സിന് അതൊരു like issues വരിക. So they'll have to call us up. So Docker came in and solved almost every problems. Like it works on my machine, it doesn't work on yours, kind of sort of that. And it packages everything into a container. But running hundreds of containers across many servers was still a mess. Like നമുക്കൊരു 10 containers ഉണ്ടെങ്കിലൊക്കെ നമുക്ക് manage ചെയ്ത് പോവാം. But what about 50 or 100 or thousands? And how about we have multiple projects? How are we going to manage them manually? So ഇതെല്ലാം നമുക്ക് ബുദ്ധിമുട്ടായി തുടങ്ങിയപ്പോഴാണ് Kubernetes നമ്മൾ യൂസ് ചെയ്ത് തുടങ്ങിയത്. So Kubernetes എന്ന് പറയുന്നത് ഒരു കണ്ടെയ്നർ ഓർക്കസ്ട്രേഷൻ ടൂൾ ആണ്. Okay, orchestration means like it decides which server to run the pods, and it restarts the containers automatically. ഇപ്പോൾ ലോഡ് കൂടുന്ന സമയത്ത് ഓട്ടോമാറ്റിക്കലി സ്കെയിൽ ചെയ്യും. ആൻഡ് ലൈക്ക് എങ്ങനെയാണ് കമ്മ്യൂണിക്കേഷൻ പോവേണ്ടത്, ആ ഒരു കമ്മ്യൂണിക്കേഷനെ തന്നെ ഹാൻഡിൽ ചെയ്യാനായിട്ട് ക്യൂബർനെറ്റ്സിനെ കൊണ്ട് പറ്റി. സോ അതാണ് പറയുന്നത്. ആൻഡ് മൂവിങ് ടു ദ കോർ കോൺസെപ്റ്റ്സ്, ഈ ക്യൂബർനെറ്റ്സ് എന്ന് പറയുമ്പോൾ തന്നെ ഈ ഓരോ വാക്കുകളായിരിക്കും നിങ്ങൾ ഒരുപാട് കേൾക്കാൻ പോകുന്നത്. ഏറ്റവും ബേസിക് സാധനമാണ് പോഡ്. ഓക്കെ, പോഡ് എന്ന് പറയുന്നത് ഒരു ഏറ്റവും സ്മോളസ്റ്റ് യൂണിറ്റ് ആണ്. ലൈക്ക് പോഡ് എന്ന് പറഞ്ഞാൽ ഐ ജസ്റ്റ് കവർ ഇറ്റ് അപ്പ്. സോ പോഡ് എന്ന് പറയുന്നത് നമുക്കൊരു ക്യൂബർനെറ്റ്സ് ക്ലസ്റ്റർ ഉണ്ടാവും. ആ ഒരു ക്ലസ്റ്ററിന്റെ അണ്ടറിൽ നമുക്ക് മൾട്ടിപ്പിൾ നോഡ്സ് ഉണ്ടാവും. ആൻഡ് ഇൻസൈഡ് ഈച്ച് നോഡ് there will be multiple services and namespace and deployments. And inside that comes the pod. So pod is the smallest unit. Okay. And what does pod contain? Multiple containers. It can contain multiple containers. Maybe an application front end running as a container, along with some sidecar container. Like it can have multiple containers running in a pod. So maybe you can run front end and back end in single pod. Okay, so that's what's a pod. And a node, it is more or like a server. Okay, like a VM or a desktop. It's actually like a machine. And here is where the pods run. And the cluster is the whole thing, like a collection of nodes which is managed together. And the deployment is how you tell the Kubernetes like what to run or when to run. Like you can say like you'll be writing a configuration where you'll be saying, okay, I need to run 3 copies of your application, of your front end or your back end. What all environment variables should be there, and everything like that will be written in the deployment. And the service is a stable way, like it's a stable connection to your pods. And when I say of pods are very like they get deleted. They are very short lived. So pods are actually stateless containers. Stateless എന്ന് വെച്ചാൽ pods doesn't store anything. ലൈക്ക് നമ്മളുടെ ഡേറ്റാബേസ് ഒക്കെ പോലെ ഡേറ്റാബേസ് ഒക്കെ ഡിലീറ്റ് ആയാൽ എല്ലാ ഡേറ്റയും പോവില്ലേ, നമുക്കത് റിക്കവർ ചെയ്യാൻ ലൈക്ക് ബാക്കപ്പ് ഉണ്ടെങ്കിൽ പറ്റും, അല്ലാതെ റിക്കവർ ചെയ്താൽ മാത്രമല്ലേ നമ്മളുടെ ആപ്ലിക്കേഷൻ റൺ ആയിക്കൊണ്ടിരിക്കുള്ളൂ. ബട്ട് പോഡ് അങ്ങനെയല്ല. പോഡ് എന്ന് പറയുന്നത് ഡിലീറ്റ് ആയാലും ആ ആപ്ലിക്കേഷന് പ്രശ്നമൊന്നും ഉണ്ടാവില്ല. അതിനെയാണ് നമ്മൾ സ്റ്റേറ്റ്ലെസ് എന്ന് പറയുന്നത്. സോ ഈ പോഡ് എന്ന് പറയുന്നത് എപ്പോഴും റീസ്റ്റാർട്ട് ആയിക്കൊണ്ടിരിക്കും. ഇറ്റ്സ് എ വെരി ഷോർട്ട് ലിവ്ഡ് കണ്ടെയ്നർ. സോറി ഫോർ ദാറ്റ്. ആൻഡ് ലൈക്ക് എവറി ഒരു 15 or 30 മിനിറ്റ്സിൽ റീസ്റ്റാർട്ട് ആയാലും it should not affect the application. Okay, so the service always like അത് ഞാൻ പറയാൻ കാരണം എന്താണെന്ന് വെച്ചാൽ പോഡ്സ് റീസ്റ്റാർട്ട് ആവുമ്പോൾ അതിന്റെ IP മാറിക്കൊണ്ടിരിക്കും അല്ലെ. പോഡ്സ് റീസ്റ്റാർട്ട് ആവുമ്പോൾ പോർട്ടിലേക്ക് റീച്ച് ചെയ്യാനായിട്ടുള്ള ആ ഒരു IP അതിന്റെ ഒരു URL അങ്ങനെയുള്ള കാര്യങ്ങളെല്ലാം മാറിക്കൊണ്ടിരിക്കും. സോ സർവീസ് മാത്രമാണ് ഈ പോഡിലേക്ക് ഡയറക്ട്ലി കണക്ട് ചെയ്യുക. ലൈക്ക് സർവീസ് നമ്മൾ പോഡിലേക്ക് അറ്റാച്ച് ചെയ്യുന്നത് കൊണ്ടാണ് ഈ പോഡിന്റെ IP മാറിയാലും നമ്മൾക്കത് ലൈക്ക് എപ്പോഴും ആ ഒരു കമ്മ്യൂണിക്കേഷൻ കീപ്പ് അപ്പ് ചെയ്യാൻ പറ്റുന്നത്. ആൻഡ് നെയിം സ്പേസ് ഇസ് മോർ ലൈക്ക് എ ഫോൾഡർ. Like it's used to separate the resources. Like maybe we can have a folder or a namespace for the front end, and another namespace for the back end, another namespace for monitoring, another namespace for database, something like that. So now let's get into the Kubernetes architecture. And as you can see, this is the cluster. This whole thing is the cluster, and this is the control plane or the master. So when talking about the Kubernetes cluster, it actually follows the master slave model. And this is the master, and these two nodes are the slaves. This is called like the master is called the control plane, and the nodes are the workers. Okay. And these are the components inside the master, and these are the components inside the slave. So as you can see, this whole thing is a node, and here comes a namespace, and inside that is the pod. We can attach a service as well into this, but let's see that later. Okay, so now let's see all these things in detail. So the control plane is actually the brain of the cluster. This like if the master is tampered somehow, it takes much time to recover. Okay. So that's why many of the cloud services, like cloud providers, offer the managed Kubernetes service. If you have heard of like AWS, GCP, and Azure, they are the major providers, and they provide the managed Kubernetes clusters. So what it means is that they will be managing this master or the control plane on their side, on their infrastructure, and we don't have to bother about it. Why they are doing it is because once master is lost, it will be very hectic for us. So that's the thing. So now let's get back to the architecture. And the control plane has majorly 4 components: the API server, the etcd, the scheduler, and the controller manager. So API server is like the front door. Like every command goes in here first. Okay, and Kube API server decides where to route them. And etcd is like a key value storage. It stores the entire state of your cluster, like what should be running and what is running. Like it keeps a record of is the scheduler running, is the controller manager running, is the kubelet running, and everything like that. And the scheduler looks at new pods and decides which nodes to place them. Like the scheduler, like when we are deploying a new application and it contains 3 replicas, okay? We need 3 copies, like these 3 pods. So the scheduler goes into the node 1 and sees if node 1 is capable to hold these 3 pods. If yes, the scheduler is the one who deploys these 3 pods into node 1, who decides. Okay. And the controller manager watches the state of the cluster. Like it makes sure everything is matched. So if suppose we ask for 3 replicas of this pod and only 2 of them are running or only 1 is running, then controller manager keeps up the track. Like controller manager increases the count and ensures that all the 3 are running. And these are the workers, and kubelet is like an agent on each node. Kubelet runs on every node. Okay, and it gets the instructions from the control plane. Kube proxy is used to handle the networking part, like the port communication, port-to-port communication, and things like that. So we'll be looking at that later. Or maybe I'll cover it up right now. Okay, so consider this as a namespace. Okay, this box is a namespace and it contains 3 ports. So these 3 of them can communicate with each other anytime without any limits. Okay, but this port cannot communicate to this port unless like they can really communicate, but we can also place a restriction on the communication. By default, they can communicate with each other, but we can restrict that if in case of a production environment or something, and we don't want our front end to communicate with the databases, right? So it all happens through the backend, right? So consider this as your front end and this as your database. Okay, and they both are different nodes and they both are in different namespaces as well. So you can place a restriction or it's called network policy. So you can enforce a network policy saying that the workloads in node 1, or you can specify which workloads. The front-end workloads should never communicate with the database workloads. Or you can place it in a namespace level, saying the ports in the, all the services in the, or the containers running in the front-end namespace should not be allowed to communicate with the services running in the DB namespace. So that's how you restrict the communication. Okay. So the main thing is like during the demo as well, there is nothing else to like throw your thread out. It's just you'll have to take care of these ports. That's all. All the rest of the things are managed. Okay. And now let's go to kubectl or kubectl. So kubectl is the main tool for you to talk to a Kubernetes cluster. Okay. So just like how you use, like you want to list the containers or the Docker images, you use the keyword as Docker, right? So here you use the keyword kubectl or kubectl, okay? And these are the most common commands you will be using when using Kubernetes. And the first one is kubectl get ports or the get. So get, what this command does is kubectl get ports, it lists the running ports. Okay, it just shows a list of what all pods are running, how many containers are running, and sort of things like that. Next thing is kubectl get all. Kubectl get all gives you a list of all the resources in the namespace, in a particular namespace. So if you specify a namespace, you will be seeing the resources in a particular namespace, and you can do that with the -n, and then you can give the namespace name. Okay, and then the next one is kubectl apply -f deployment.yaml. So apply -f is used to create or update the resources from a YAML file. Okay, so we use YAML for writing the deployment files, the services, the pods, and everything. Okay, so if you want to create an application or a deployment or a pod, you can just use a kubectl apply -f. Okay, so it's used in two ways. The first way is for the first time creation. Like if you have an empty cluster and you are going to deploy your first application, then what it does is it creates that application, creates that pod, creates that service, or whatever is attached to that. And the next time or the second time you do a kubectl apply, what happens is the resource is already existing. So it just applies the change. It's just appending or overwriting the change. Okay. So that's the two applications of apply -f. Now kubectl describe pod. So describe is used to see more details about a resource. Say here it is given pod. So you want to know more about the pod, like which port is it running on, or what is the CNI attached, or what image is it taking, which Docker image it is running on, or are there any new events that has happened, or what is the CPU it is using, or something like that. You can use kubectl describe pod. The next one is kubectl logs. So as the name suggests, it is used to see the logs, the application logs. Next one is kubectl exec. Exec -it, the port name and sh. So it is similar to doing an SSH into the VM, but in this case, it is just an SSH to the port, just to see what is inside that port, what like you can just use it to see are your cores updated or something like that. Okay. The next thing is kubectl delete -f. So delete, as the name suggests, it is used to delete the resources defined in the file. So it deletes all the resources which is described in this deployment.yaml file. And the kubectl scale deployment is used to scale the application up and down. Okay, so like you are running an application with one replica, okay, with a single port, and you feel like there are more users coming in, and you want to manually scale up the replicas for what do you call it, for a couple of hours or something. And you can use this command to scale the deployment. You can set the rules like it should scale up automatically if the CPU utilization or the memory utilization or the number of hits to the application is around above 50% or above 60%. Okay, so here it is setting the replicas to 4. Similarly, you can set a maximum and minimum replica. Like it should be minimum, there should be minimum 2 replicas, and maximum, it can scale up to maximum at 10 of replicas. So you can set that as well. Now we'll see about config map. So config map is actually what you call, okay. So imagine you have a container image for your web app. Okay. So if you hard code the database URL or like the app environment inside that image, you have to rebuild it all the time, right? If you are hard coding it, you will have to rebuild and redeploy like those images every time. But we should never hard code the values. It's considered unsafe, right? And it's also not the best practice. So if someone gets your code, they'll have everything they need, right? So a config map lets you store configuration, like the environment variables, and inject into your containers at the runtime. So it just replaces your variables only when the container is running. And the key rule is that the config map is for non-sensitive data. So you should never use a config map to store the database password or the API key or maybe Redis passwords or some certificates or some private keys and all. You should never use config maps. So in that case, you should be using secrets. So we'll discuss about that. But before that, just have a eyes on this. So here, this is a config map, and its name is web app config, and it has 2 variables. One is app env and its value is demo. App version, its value is this one. So this entire thing. Okay. So what this means is that they are not very critical variables. So you can use them in the config map. Now coming to secrets. Secrets are like config maps. Like they are used to store the key value pairs or certificates or API keys, all those sort of things. But it is much more safer than config maps, but not pretty much the best. Okay. So they are like the secrets are mainly used for storing the sensitive data. Okay. So you can store your database passwords and all as a secret. So as you can see here, this is a secret and its name is web app secret, and it stores the DB password and API key. So if you can see here, like I'll just go back to the config map. If you see here, the app env value was demo, and its like normal letters, normal human language. But if you can see here in the secret, the variable is DB password and its value is not human readable, right? So what we do is these secrets store the values, not the variables, just the values as base 64 encoded value. Okay, so if you can see here, I'll just go to base 64 and I am just encoding. This is my password. Okay. And if I encode this, I'll be getting a value like this. So this value is stored in the secrets. Okay. So it's just an encoding and it's not an encryption. So that's why I mentioned that it's safer than config map, but not at most safe. So you can make the secret safer. For that, you will have to use a key vault or what you call or an additional layer of safety there. Okay, but to start with, you can use secrets. Now, what is the difference between config map and secret? We already discussed this. So config maps are for everything that's configuration but not sensitive, like whatever. Okay. But secrets, they store the credentials, passwords, the API keys, certificates, and everything. So both are injected into the ports the same way as like env variables or the volume mounts or something. Okay. The difference is how Kubernetes treats it. Kubernetes treats config map as plain text, but secret as the base 64 one. Now, let's go to a demo. So I am using kind here. So if you don't know, this is kind. And kind is actually a Kubernetes tool, which we can run in our local system just for learning purpose and all. So I have already installed kind. You can just follow this documentation to just download it. Here is it. And I have already installed kind over here. So I haven't done anything else. Just that I have installed it. Okay. Now, the first thing we have to do is to create a cluster, right? So let's start a cluster. Let's start creating a cluster here. Kind create cluster and the name of the cluster. Maybe you can say MuLearn. Okay. It didn't work. So kind create cluster. It's just preparing. It is preparing the nodes. It is configuring. It's starting the control plane. You can also have multiple nodes here, but still it's a ready to use Kubernetes cluster. Okay. Now, kind get clusters. Now we have one cluster over here. Okay. Now kind create namespace. This is okay. Kind get node. Sorry. kubectl get node. So we see here there is a control plane. Okay. Now let's create a namespace, because I said that namespace is the folder level separation. So sorry, create namespace. Create namespace test, or maybe MuLearn. Okay, it says it's created. Let's see. kubectl get namespace MuLearn, and we see it is active. Okay, now you can use shorthands like kubectl get ns. Ns means namespace. Okay, so you see that there are multiple namespaces already active. Okay, so these are the already existing namespaces when the cluster itself got created, and we created an additional namespace called MuLearn. Okay, now let's just create, or let's see if anything is there already. So kubectl get all. What is there? It just has a service called Kubernetes. Okay. Now kubectl create. What should we create? We can try creating kubectl. Okay, maybe we can try creating something. What should we create? Okay, maybe we can try running an Nginx pod. So kubectl run. This is the easiest way to run a container. So run Nginx. Actually, Nginx is the name which I gave, or maybe I can give Nginx container. Okay. And I need to specify an image, which is Nginx. Or Nginx, it takes Nginx latest. So it says pod Nginx container is created. Okay. Now let's get all. And it says there is a pod. Okay. Now let's just get a list of all the pods. Okay. So you can do kubectl get pods, or you can use the shorthand. Okay. Now if we can see here, there is an Nginx container running, and 1 on 1 means there are a total of 1 container and all of that is running. Okay. Now if you have had multiple containers in this pod, it will be showing 2 on 2 or 1 on 2, like that. Okay. Now I just need more information about this container. So I use describe command and kubectl describe pod, and I give the name of the pod. Okay. And it gave me all the details about this Nginx container. What all details did it give me? So the name of the container is Nginx container. The namespace is default, and the priority is 0. There's a default service account used. You can also use a custom one, but it's not for a beginner. Okay. And there are this is the label it used. This is the start time. What is its status? It's running. And this is its IP. Okay. Then what all containers are in here? So it just has an Nginx image. It took that image from Docker Hub. It started at April 4, this time, 2 minutes back. Is it ready? Yes. And did it get restarted? No. Then what all? And so much details about it. Okay. Now here you can see the events. So what all happened? So first thing, the scheduler assigned my pod into the node. Okay. And after that, it pulled my Nginx image and the container got created and it got started. Okay. If you can see here, this is what exactly we discussed during the Kubernetes architecture. So the scheduler assigned my container into a node and the kubelet did everything else. And now the scheduler will be checking if my container got started. Okay. Now, if I want to have a straight view about my pod, so then you can use this command kubectl get pod -o wide. This is used for a wider view. So what all you can see here? You can see the IP of the pod, you can see which node is it, and you can see the readiness gates. So readiness gates is nothing but you can set the health checks. Like the main feature of Kubernetes is that it can automatically detect the health of the pod and it can automatically handle that, right? So you can write a readiness gate saying, what you can say, your health check path is /health. Okay, check in the /health path every 15 seconds or every 30 seconds. If you are not getting a 200 back, it means the application is down. So it will automatically restart this pod. Okay. Now, how to delete this pod? kubectl delete pod and the pod name. Now if I give kubectl get pod, nothing is there. Okay. Now, if you want to run the same container in another namespace, which is the one which we created, okay, then what to do? kubectl run nginx container image nginx -n and you give the namespace name. Now, if you give a kubectl get po, there is still no resources in the default namespace, which means by default, all the containers go into the default namespace if not specified. Okay, so still there are no containers or no resources in the default namespace. But if I am specifying the namespace, the container is here. Got that? Now, I have to check the logs of this container. So kubectl logs, and I give the port name and I give the namespace name. Now it says it gives me the logs. Now if you want a real-time log, there is nothing, just give a -f. Okay. Now you get to see the live logs. Okay. Now maybe, yeah, let's just go through few things. Okay. Now, I already created this some files, but let's just discuss and go over. And I'll just open it in my code. Okay, so this is a deployment file, and like you can, if you want to practice something, you can always use the Kubernetes documentation. This is a Kubernetes documentation, and you have everything over here. And if you can search deployment here, you get all you want to create a deployment file. Okay, so you can use the same. Okay, that will be better, right? Okay, maybe I'll just create a new one. I'll just name it as app.yaml, and I'll just copy paste this one. Okay, now if you can see here, this is the API version. So the deployment will be having an API version. The secret will be having an API version, and like they can't be changed. Okay. Now, what is it? It's a deployment. So for secret, the kind is secret. For the config map, the kind is config map. Okay. Now, the metadata is actually like a label to your container. So maybe just to identify your application. So is it a part of your, like, is it a component of front end or back end or DB or whatever? Okay. So now here, what we have is it's an Nginx deployment, and the app is Nginx. Okay. Then comes the spec of the container. Okay. So it says the replica should be 3, which means when we run this or when we create this or when we apply this, we'll be getting 3 replicas or 3 Nginx containers. Okay. And what is selector? Selector is used to attach, like it's just used to what do you call, all the 3 containers or the 3 replicas should be having a label like Nginx, and it will be helpful for us if we want to attach a secret or a config map later on to this container. So we will have to use this app as Nginx label. Okay, it's same as the template. And now we have another spec inside which we specify our container, which is Nginx and the image version. And we also mention which port it should run on. Okay, now let's try to apply this one. Okay, so I'm just using a kubectl apply -f and app.yaml. Okay, and app.yaml to the default namespace, let it be. Okay, so apply -f means the first time I don't have anything, so it will be creating it. Okay, now when I do this, deployment created. So now let's just check get deployments. Okay, it says there is a deployment called Nginx deployment, and it should be having 3 of them, three replicas, but 0 are ready, which means nothing got created yet. Okay, now if I do this again, it says 3 of 3 are ready. Now let's check the pods. kubectl get pods, and you see there are 3 deployments or the 3 pods running for this deployment. Okay, now if I want to see if it is really running, I can port forward this. So kubectl port forward this port 80. It's already mentioned that it's running over port 80, right? So if I do that, I get to see the Nginx homepage. So it's really working, right? So that's all about the deployment. And now let's consider the next part of the apply. So here I changed my replica count into 2. Okay. Now what happens if I just apply it? Okay. And now if I take get port, what happened? One replica vanished away. So that is the difference between create and apply. Like the apply for the first time and the second time. Okay. Like if you have any doubts, you can ask me in middle. No issues. Okay. Now let's again go to the documentation and let's see about the services. Okay. How to attach a service into this same deployment file. So here service can be svc. Okay. This is the service. Okay. So the version is v1. Okay. If you can see in the app.yaml file, it was apps v2. Okay. Now in the service file, it is just v1 and a kind of service. And the name can be, here it was Nginx deployment, right? So here we can give us Nginx service. Okay. And we are also providing some labels over here. So similarly, we can provide the labels here as well. Okay. Now, the spec, inside the spec, it is Kubernetes.name is my app. So we don't have a my app. Instead, we are having an app called Nginx, right? So here I am replacing my app with Nginx. And in the port, we have the protocol as TCP and the port is 80 and the target port is also given. So we don't have to use this target port for now, and we gave them as port 80. Okay. Now let's just apply this one. Okay. kubectl apply -f svc.yaml. Okay. There is some issue with here. Maybe we don't have to give it here. Let's try now. Yeah, it got created. Now, if we give, so for service, kubectl get svc can be used. Okay, so it says there is a service called Nginx service, and it runs on the port 80. Now, you see here that the type of this service is cluster IP, right? So there are 3 types of services in total. One is cluster IP, one is node port, and one is load balancer. So the main difference between these 3 are the cluster IP means the cluster IP will be accessible. So this IP basically, okay, this IP will be accessible only within this cluster. Okay, only within this cluster, this IP will be like accessible. if I am using a node port, the port numbers should be starting with 30,000. Okay, instead of 80, it should be starting with 30,000, and it will be available in the machines within the same network. Okay, and if I am using a load balancer, it will be available in public. Okay. Now, yeah. So if you look at here, we have added one more field. So that is the resources or the resource limits. So if we are not specifying the resource limits for a container, what will be happening? There can be resource like, what do you call, there can be overuse of resources. So maybe an application requires only 10 MB to run, but when 100 MB is made available, it will utilize more, right? Or maybe we won't be planning for a high budget for that, but it overuses the resources and kills, right? So it is important to specify the resource requests and limits. Requests means minimum amount of CPU and memory each container should be having to run. Okay, so it means that when this container is getting started, when this container gets started, it should be having 100 M of CPU and 64 MB of memory. It should be there. Okay, limits means by the time people are using this application and the hits to the port comes, it can use till 250 M CPU and 128 MB of memory. But it shouldn't exceed this limit. That's what it is mentioned. Okay. Now, this is what I told you about the node port. It starts from 30,000. Okay. Now let's just see about the secrets. Okay. The secrets and the config map. And I'll just go into the config maps and we'll just open it. Okay. So this is the deployment file for the web app. And here I have given the container port as 80 and the resource request limits is there. Now, the first scenario is has env variables. So I told you that we can, there are many ways to inject or to use the config maps, right? We can either mount them or we can use the config maps directly, or we can provide them as variables. So they are giving us env variables, the normal env variables, and we can specify each key. So what this says is there is a variable called app-env, and there is a config map named web app config. So you should take the value of app-env only from this config map with the variable name app-env. So maybe I have saved in the config map in a different name. Maybe I can save here as application env, right? So this is what it means. And similarly for the app version. Now, inject the secret values as env variables. So we can use the secret values. right? This is a secret, and the secret can be also attached as each variable. Okay. Now it can be mounted as files. Like say we saw a file about the we saw a web app running over the Nginx, right? So instead of the welcome to Nginx message, I can show a random message. Okay. And we can also pass it through the volumes. Okay. This is what it means. And in my config map, I have given a sample, what do you call, an app env and the app version here. And let's see what happens when we apply that. So before that, I'm just, okay, get port, get deployed. And I'm going to delete this this deployment. And if I give a kubectl get port, nothing is there in the namespace. And now I'm going to just create what we just saw. So kubectl apply -f, and I just applied the deployment first, and then I'm just applying the service, then I'm applying the config map. Okay, now everything is created. Now let's just see the config map. Okay, so kubectl describe config map web app config. Okay, now if you can see here, you can see in plain letters the value of app.env and the version. Also, you can see other files which I have added. Now, if I'm going to get SVC, you can see a web app runs on node port on port number 30080. Okay. So literally, I should be able to see this over 30080, right? But it won't be visible since I am already inside a cluster, and that cluster network and my network is different. So what we will do is kubectl port forward. We can do port forward for both servers as well as the ports. Okay. Now I am doing a port forward for web app. In which port? In port 80. Okay. So it is pending. Now let me just kubectl again. Okay. It got a config error. Now let's see. Okay. Now how will we? Okay. How can we check what the error is? So we'll be first doing a kubectl describe port and give the port name. Okay. So it is saying mount volume setup failed. Okay. We don't need a mount volume setup. And also it says the secret is not found. Okay. Now let's create the secret as well, which is inside the secret folder. Okay. Kubectl apply -f secret. Okay. Now let's get the code here and delete them. Okay. Delete both of them. We can delete both of them by just copy pasting the names of both ports with a space, and they got deleted. Okay. Now if I am getting the port, both of them are running. Now I can just port forward it and take the localhost. Now it says welcome to Nginx. If I refresh, it says welcome to Kubernetes. Okay. Now it says the environment is demo and app version is v1.0. How did it get this? So this message comes from config map, and these values also comes from config map. Okay. So now if I'm stopping this and doing a kubectl get secret, and kubectl describe secret, what are you expecting to see inside the secret? So it doesn't show any values over here, right? It doesn't show what is the value. Now, if I do a kubectl get secret, web app secret minus o, yeah. Now I can see the values of the API key, the DB password, the DB username, all in the base64 encoded form. Now, if I want to see what is the value of the database password, I'll just copy it and I'll just go over decode and I'll just paste it and I can see super secret 123. Okay. So this is how everything works, and okay. So we saw all these. Okay, except the exec. Okay, now let's see that as well. So I'm just listing out the pods and how can we SSH into the pods. So I should use exec minus IT, and I will have to give the port name SH. Now you see the shell, and I see you see the files inside this. Okay. So this is it. Any doubts on the demo or something? Okay. Now we have covered the basics, but still, like, I'm not sure which stream are you looking into. Maybe some of you are interested in DevOps, or maybe some of you are developers, but still, anyway, if you are passionate, you can research more on these. I'll just give a brief on them. So Ingress actually lets you to route the traffic, like route the external traffic into the cluster. And HPA is the horizontal pod autoscaler. Like, it is what I mentioned before. Like, if the memory or CPU utilization exceeds 60%, you can write a scaling rule saying it should create 2 more replicas, or scale down after the utilization reduces to 60% or 40%. So you can write those rules so that you don't have to worry about anything else. Next is the persistent volumes. In the beginning, I mentioned that the ports are stateless, right? So in some cases, you will be like in the test environments and all, you can run the databases in ports, but make sure to attach a volume so that whenever a new port comes up, the volume will be attached to that port and you will never lose your data. And also make sure, like, always use stateful sets to run your databases or the stateful files or the stateful applications. Okay. Helm is a package manager where you can combine all these files which we discussed, the service files, the deployment files, the secret files, everything combined up as a package manager. And RBAC is actually for role-based access to what you call, for the fine-grained access to the cluster. It's more like who should have this access to this cluster. Okay. And as I mentioned before, Kubernetes is coming as a managed service in most of the clouds, and most of them give free credits as well. So just try on a hands-on, and if you're not interested in that, you can always run a kind cluster as easy as I ran now. And so try that out. And if you have any questions, we can connect over LinkedIn. My name is Varada B on LinkedIn. You can always connect over there. Apart from that, if any questions, you can ask me now.
നമ്മുടെ സെഷൻ ഒഫീഷ്യലി ഓവർ ആയിട്ടുണ്ട്. ആർക്കെങ്കിലും ഡൗട്ട്സ് ഉണ്ടെന്നുണ്ടെങ്കിൽ ഇപ്പം ചോദിക്കാം. സോ ആർക്കും ഡൗട്ട് ഇല്ല എന്ന് വിശ്വസിക്കുന്നു. This was our last session of this DevOps Bootcamp, and thank you Varda ma'am for taking this last session. വളരെ നല്ലൊരു ക്ലാസ് ആയിരുന്നു, ലൈക്ക് ബിഗിനർ ഫ്രണ്ട്ലി ആയിട്ടാണ് പഠിപ്പിച്ചത്. താങ്ക് യു സോ മച്ച് ഫോർ ദാറ്റ്. ആൻഡ് ഓൾസോ I want to thank every participant of this DevOps Bootcamp. ഈ 4 സെഷനിലും ആക്റ്റീവായിട്ട് നിന്നതിന് ഒരുപാട് നന്ദി. Also hope to see you in much more events, and once again thank you.
Thank you so much.